Number 7. Graph the following square root functions. State the transformations that occurred compared to the parent function of y equals the square root of x above each graph. Then state the domain and the range of the transform function in interval notation. So if we start and we take a look at this, what I first see, because we want to read the equation from left to right, is we have a minus 3 inside the function. And minus 3 inside the function means that we're going to move our graph right 3 spaces. So we've got the parent function right there beside us, so all that we need to do is we need to move our parent function 3 spaces to the right. So we're going to start here at 3, 0, and then the point 1, 1 is going to move over here to 4, 1. The point 4, 2 is going to move to 7, 2. And then our point 9, 3 is not going to fit on the graph. So there's our first transformation. We only actually have one more transformation on this one. It's the plus 1. So we're going to go up 1. And now our point that was 3, 0 is going to be 3, 1. And our point 4, 1 is going to be 4, 2. And our point 7, 2 is going to be 7, 3. And that's the picture of our graph, our given function of h of x. And I'm going to write our domain and range in set notation before I write it in interval notation. But what I think is important here is this point right there, which is our 3, 1, which I sometimes call starting point, and sometimes I call it vertex in quotation marks. But in terms of domain and range, remember that domain are the x factors and range are the y factors. From that ordered pair there, the x is 3 and the y is 1. And then we're looking at everything in terms of, in comparison to the black point there. So on the black point for domain, everything's going to be to the right of that, which means that it's greater than or equal to 3. And with regards to the black point, all of the green values are above that, so it's going to be greater than or equal to 1. Now, it says to write in interval notation. So what's happening is we're going to start at 3. We're going to keep going up. So it's going to be 3 to infinity. And it's the same idea here. We start at 1 and we keep going up. So it's going to be 1 to infinity. So it's 3, and I think I missaid that, but it's 3 and it keeps going to the right forever and ever. And then 1 and it keeps going up forever and ever. Letter B. Again, looking at our transformations. And there actually are 3 transformations on this particular graph. And I want to point out to you that negative is separate from the 1/2. Because the negative reflects our graph over the x-axis. So when we draw this, our points there, we've got them to the left to look at from the parent function, but 0, 0 is going to stay 0, 0. And as we reflect over the x-axis, 1, 1 is going to become 1, negative 1. And 4, 2 is going to become 4, negative 2. And 9, 3 is going to become 9, negative 3. There is our reflect over the x-axis, and again, that's only the negative. Because the next one, with the 1/2, is going to be a vertical compress. And it's going to be very hard to see on this graph. But if there's any good news for me, it's that 0, 0 is still a point on the graph. But instead of 1, negative 1, we still are going to go 1 space to the right, but we're only going to go down 1/2. So it's going to be 1, and it's going to be negative 1/2. And 4, 2 is going to become 4, 1, negative 1, 4, negative 1. And 9, negative 3 is going to become 9, negative 1 1/2. So let me say those points again, just so you can make sure to get them. 0, 0, 1, negative 1/2, 4, negative 1, 9, negative 1 1/2. we have one more change. It's plus 3 inside the function. And that's going to be left 3. So we're going to take that green graph now, and we're going to move all of those points left through. So 0, 0 is going to move over here to negative 3, 0. And trying to move it just a little bit more. But 1, negative 1/2 is going to move to negative 2, negative 1/2. And 4, negative 1 is going to move to 1, negative 1. And 9, 1.5 is going to move to 6, negative 1 1/2. And there's our picture. What I want to point out now is going to be this black point here, which is going to be how we come up with our domain and range. And I'm going to do it in set notation, and then we can convert it into the interval notation. But our order pair that I am marking in black here, and messing up badly because the board's a little bit disoriented, but it's negative 3, 0. Is that order pair? So when we look at domain, we're dealing with the x values, and we're looking at the range, we're dealing with the y values. And our x value in that order pair is negative 3, and our y value in that order pair is 0. Just like the previous problem, all of the points, all of the red parts of the graph, compared to that black, are going to the right. It's going to be greater than or equal to negative 3. And all of the y values of the red part of this graph are below the black point, so this is going to be less than or equal to. So we're going to start at negative 3 when we put this in interval notation, and we're going to keep going to infinity. And on this one, 0 is going to be the highest point of the graph. We start at the lowest possible value, which is negative infinity, and we're going to go to 0 for our interval notation. Turning our paper over for letter C, k of x equals 3 times the square root of negative x minus 7. We've got our parent function. We want to list our transformations. And our first transformation comes from 3. It's going to be a vertical stretch. We're going to start on 0, 0. And then we're still going to go one space to the right. But instead of going one space up, our vertical stretch is by a factor of 3. So we're going to go one space to the right and up 3. So that order pair is 1, 3. 4, 2. We're going to go 4 spaces to the right, but instead of going 2 up, we're going to go 2 times 3. So this next point is going to be 4, 6. And our point 9, 3, we're still going to go 9 spaces to the right, but instead of going 3 up, we're going to go 3 times 3. So it's going to be 9, 9 is going to be that third point. There's our vertical stretch. Our second transformation is occurring because there's a negative underneath the square root. That means that we're going to reflect over the y-axis. And 0, 0 is still going to remain as part of our graph. And we're going to take that point of 1, 3, and it's going to become negative 1, 3. I'm going to take the point 4, 6, and it's going to become negative 4, 6. 9, 9 is going to become negative 9, 9. And there's our reflect over the y-axis. We have one more transformation, and that is minus 7. So this means that we're going to go down 7 on the graph. So 0, 0 is no longer going to be a point. We're going to move this down 7. 0, 0 move down to 0, negative 7. And then negative 1, 3 moves down 7. So we're going to be at negative 1, negative 4. And 4, 6 is going to move down 7. So it's negative 4, 6. So it's going to be negative 4, negative 1. And negative 9, 9 is going to move down 7. So it's going to be at negative 9, 2. And there's our completed graph. Once again, the point that I want to point out is this black point here, which is going to be 0, negative 7. Because I'm going to write the domain and range in set notation before I put it in interval notation. So domain are the x's, range are the y's. Our x value in the order pair is 0, and our y value is negative 7. And compared to the black point, we're going left of that black point, so we're going to have less than or equal to. Compared to that black point, we're going to be above, so it's going to be greater than or equal to. So again, you have to go in order. So the smallest value is going to be negative infinity, and 0 is going to be the last point on the graph. Negative 7 is going to be the first value on our graph, and then everything's going to be above that. Again, lowest to highest, left to right for the domain.